I'd like to show you some of the improvements, and some of them are quite significant in the way that we actually deal with 3D geometry and material information in general and tessellation. So to start with, I'm just going to start with this basic 3D text. And the first thing that I'd like to point out is if I double-click on my text object, you will find a new button here that is called Multimaterial. And if I activate it, something in the schematic happens. You see that 3 new nodes get connected to the geometry, and those are called object groups. And you'll notice that they are actually called front, extrusion, and back. And what this allows you to do is to actually control different properties of the front side, the back side of the text, and the extrusion of the text. We can do this on text objects because obviously we know that typically their topology is always comprised of the same things, you know, front, back face, and the extrusion. On regular geometries that you would have imported, well, Flame doesn't allow you to create the object groups. However, one thing that is really interesting is that if you import a geometry or an FBX geometry, for example, that has object groups specified, that were specified in the application, they will actually get preserved through the FBX import. So in the context of 3D text and GMask, both share the same sort of assumptions on the topology, and so the minute that you extrude a 3D text or a GMask, you'll be able to actually activate multi-material and get a separate control over the front, the back, and the extrusion face. So let's see what you can do with this. The first thing that you can do is, first of all, use a new material node that's here in the node bin, and you'll notice that when I drag this, it gets automatically connected to the currently selected object group. And what this will allow me to do is essentially control the material information that is typically nested inside of the geometry surface information. And you will recognize here the specular, the ambient, diffuse, transparency, and shininess controls. And if I connect a material node to an object group, any information that I put inside the material node will override the geometry information that is currently stored. The material node can be applied not only to a 3D text, it can actually be applied to anything that has a surface property, and that would include an image as well. So let's see what happens if I switch back to my perspective and I start changing the diffuse color. You will notice that that the result is that the color only changes on the front face. And because this is a node in the schematic, I can go ahead and actually decide to parent also another object group. And at this point, what this will do is automatically copy the same material information onto the back face. So if I rotate my 3D text, you will notice that both the front face and the back face now are blue. And now, if I go ahead and select the extrude object group and add another material, I can go ahead and this time change the color of the extrusion, thereby providing me with a lot more control over how I actually want to segment my text object. Material objects are something that you can also texture further. As I mentioned earlier on, any object group that was specified in a 3D application will be preserved through the import. We've actually even changed the way that for example, a 3ds Max geometry would be imported inside of the application. So if I go ahead and let's say import a 3ds Max, any 3ds Max geometry, you will notice that it appears with a material node, and it also appears with an explicit diffuse. So this is an important thing to understand. The material can actually be textured, and because we now explicitly expose the texture, it means that you can replace it with anything that would be in your media list. So if I go into the media and select apply, you will notice that my cube here gets automatically textured with whatever texture I decided to apply to it. And it obviously preserves the UVs and the material information that are specified inside of the geometry. Again, this will apply to FBX and 3DS geometries. So this is something that you can use to your advantage. To go back to this example here, I'm just going to unhide the geometry, and again, highlight the fact that material can actually be textured. So let me just reset this so that it's back to something that's not necessarily colored. And let me actually show you how you can actually even texture it with a substance texture. So if I go back to my node bin, to my maps, and I go ahead and go to the substance texture, I can go ahead and select any texture that I see fit. And you will notice that it will get automatically parented to the material node. The shader also will get automatically connected to the geometry. If I switch back to the perspective, I see that I just have a little problem, which is my relief mapping that is switched on. If I switch it off, there you go. You see my my texture gets applied only on gets applied on the front and back face of my object. And the other thing that I'd like to show you is that we've also considerably changed the way that the tessellation is applied to 3D text objects and GMask extruded objects. And to you will notice that now in the 3D text and the GMask object, you actually have a new submenu which is called Tessellation. And so to see the effect of this, I'm just going to switch to wireframe so that you see. So this is typically the type of tessellation that was used in previous versions. So for compatibility reasons, it's still there. But if you go to the tessellation submenu, you'll see that by default it's still using the GLU tessellation algorithm, but you now have access to two different other techniques, and those are actually taken from Softimage. So we work closely with them to incorporate some of the tessellation algorithms that they implemented also to do text tessellation, and so you will notice that you can actually get a much more pleasing tessellation within your objects. This is using the Delaunay algorithm, and where you can actually control explicitly the number of maximum vertices and the maximum area of each polygon. And as you see, you get a much more pleasing, if you change also the minimum angle, you will be able to actually control much better the way that polygons get spread across the surface. And I can control the maximum area, so I can actually get to a result that is a lot smoother. On both the front, the back face, and of course the extrusion. This can also be accumulated with subdivision, which provides with a lot more flexibility and control. The other option is medial axis, which has another set of parameters. Essentially, it's different algorithms to achieve the same thing, and you should experiment with whatever provides you the best results depending on what it is that you want to do. And of course, one of the biggest advantage of having this is that displacement mapping, for example, in 3D geometry is going to be a lot better now than it ever was before. So to give you an example here, let me just hide this geometry, and I have this GMask here that I import, and it's currently being displaced. And you will notice that the quality of the displacement map that I get now on my geometry is significantly higher than it ever was before in previous versions. So here in this context, what you have is I have this geometry that is being tessellated with the Delaunay algorithm, and I further subdivided it so that I would also be able to have like more control on the sides. So here I have a subdivision to resolution 10, and you will notice that the result is actually a lot more pleasing than it was before. So here this is a geometry that is being currently lit both by the IBL, and it also has shininess, a shininess attribute that is set to 100, and a diffuse color to sort of like a bluish color. So you would see that, again, this gives a lot more pleasing results, much more pleasing results with displacement, making actually displacement really a viable option on 3D geometry. So something to look out for. Moving on, I'd like to show you also some other improvements that were added in the way that we also deal with FBX geometry. So one thing also that is pretty cool in the 2012 release is that the FBX import in 2012 using the 2012 SDK. It's very important to note that it's with the 2012 SDK. Actually, Flame now supports geometry caching or point caching, which is a way of actually baking animation of vertices inside of the FBX. And this allows you to actually preserve. So here I have this this model here. So it's a low poly model that has animation applied to it. And as you see, it has this animation cycle that that was imported into Flame, and the animation is actually preserved inside of Flame. And this is through geometry caching or point caching, depending on how you want to call it. So the interesting thing is, as you bring this into Flame, you can still relight the geometry. So in this context here, you see I'm actually relighting it so that it can cast shadow over a floor, and the floor is actually a substance texture. And I'm using here an IBL sort of as a background image. But the point is that even though you have animation applied to it, you can still pretty much, here I've just added an axis on top of my FBX that I grouped in inside of a group, because it can be sometimes a complex hierarchy that I don't want to see. And here I can still freely move it inside of 3D space. I can scale it. I can do pretty much, you know, what I would expect to be able to do with the geometry, and actually even relight it with a light inside of my 3D space. And what you see at this point is that I've actually deactivated, as I move the light around, I actually have some adaptive degradation settings that are kicking in the node setup. I can actually, when I activate adaptive degradation, here I'm actually telling the software to deactivate the shadows the minute that I interact with anything. So if I move my camera around, or if I move a light around, the shadows actually are set to do not display. I can also have extra options like actually switch to the minimum possible resolution of my shadow maps in order to accelerate the feedback. So adaptive degradation actually is something that you may want to consider when to compensate for some sluggishness when you're doing stuff with light. So here you see I'm set now to actually switching to minimum resolution of the shadows, and you can see I can actually relight my geometry, and it's actually it's being applied on the fly into my scene. And again, my animation is preserved. So that's geometry cache. And of course, anything that supports geometry cache, and that would include cloth simulation, physical simulations, all sorts of things, can now be preserved and imported inside of Flame without having to deal, and even a character animation for that matter, without having to deal with any of the complexity of of a rig or inverse kinematics. You don't have to worry about this. It's only the animation that is preserved, and of course you can project anything on that geometry inside of Action. So that's pretty cool. And another thing that is being supported inside of Action is the importing via FBX of anything that has substance textures applied to them. So here what you see is actually a cube that was done inside of Maya with different substance textures applied to them. And so it's a slightly different format of substance textures, as they don't actually recognize the Flame shader, so they may render slightly differently when you import them via FBX from Maya. But the point is that you're recognizing the schematic here, that this is how my geometry actually appears. You will notice that it has been sliced into object groups with material nodes, and I actually have the substance information that is there. So that's kind of interesting, and I can actually on the fly decide to then change the parameters of my substance texture. So if I want to go ahead and actually change the parameters of the substance, I can. So substance, everything that is common in Flame, Maya, and 3ds Max will be preserved when you import them inside of Flame. So that's kind of cool also.